problem dealing with centripetal forces, and the problem is as stated. A ball with a 3 kilogram mass is going in a circle with a velocity of 8 meters per second. The ball is attached to a rope with a length of 0.4 meters. What is the tension placed on the rope? So first thing first is I would want to do is draw a free body diagram, which I already did. I drew the bird's eye view of the diagram, and it's just a diagram to show that the ball is actually placed on the surface, giving it a normal force and also weight. So since I already got my free body diagram, now my second step would be is to use Newton's second law. Focus on Newton's second law. So that would be acceleration equals force over mass. Well, I guess net force over mass. Now, since this is dealing with centripetal forces, the acceleration is actually v squared over r. And so I would just want to replace the acceleration with v squared over r. And just to clarify that I'm using centripetal forces over my mass. So I already stated that I'm trying to find the tension. What is the tension placed on the rope? And to make this problem as simple as possible, I would want to focus on the inward direction, the horizontal direction, since that's my tension. So I can pretty much plug in my values since I pretty much have a velocity, a radius. I have a mass. So I'm just going to bring this down here. So, and I'm looking for my attention. So, and that's my centripetal force. So, I pretty much can multiply both sides by mass. So, and now I can plug in my values. My mass is 3 kilograms. My velocity is 8 meters per second squared. And my radius is 0.4 meters. So I can plug this into the calculator. And I'm going to do 8 meters squared. I'm going to get 64. So I'll do 64 divided by 0.4, and I get 160 times 3. And that equals to 480. And that would be my tension, or my centripetal force. I'm pretty sure my unit is meters per second, I think.